Number one, here's the homework. Okay, check it quick. I'm not going to spend a lot of time on this. EVT, requirement for EVT. While you're checking, F has to be what? Continuous on the closed. Is there any other requirement for EVT? No. It's only F is continuous on the closed because it's a non-vowel. It's a vowel theorem. The non-vowel theorem, MVT, requires it be continuous on the closed and differentiable on the open. But IVT and EVT only require that it's continuous. And then when you do this, if you are continuous on a closed, you're guaranteed an absolute max and an absolute min. And what do you have to check to get that absolute max and absolute min? Say it with me. What's a candidate's test? What do you have to check? Endpoints and CVs. What are CVs? Where the derivative equals 0 or undefined. So you got to check endpoints, which are given. And then you got to check CVs, which are where the derivative equals 0 or undefined. All right, so everybody checked 1 through 4. I'm moving on. I don't think anything big on 1 through 4. Okay. Got it all right? Why does number 3 have no absolute max and min? Yeah, it's continuous up and down forever. Exactly. All right. All they wanted you to do was find critical values. They didn't even give you an interval, and they didn't ask for the max or min. They just wanted to know, can you find critical values? Because in order to do EVT, you got to be able to find critical values. So critical values for number 5, you took the derivative. The derivative was 2x, so you have to be able to take the derivative. You're going to get good at taking derivatives. Was 2x over x squared minus 4. The derivative would equal 0, where the top equals 0. Okay? But here's a problem, and I'll talk about this. 0 is not actually in the domain. And we'll talk about this in a second. And then x squared minus 4, you get negative 2 and 2. So there's no critical values, and here's why. Let me explain this. She does it a little bit differently. She uses the graph. Let me show you how to do the domain. Can anybody remind me, and I would make a big note here. I wish I had some white space. I don't have any white space. Bjorn, Blake, I need some white space, and I don't have any. Blake, I'll go over here. Is this suffice for you? Yep. All right, x squared minus 4. Can somebody remind me about just regular, good old natural log x? What's the domain have to be? Greater than 0. It has to be greater than 0. So here's the deal. X squared minus 4 also has to be greater than 0. Now I'm going to do this because sign analysis is going to be a big deal today in today's assignment. So if I wanted to figure out, she used the graph. She graphed it over here. But most of you don't know how to graph that. And she probably used the calculator. But what if you don't have a calculator? Okay, because I can look and see that the graph, the domain is from negative infinity to negative 2 union 2 to infinity. Can you see that by looking at the graph? Yeah. So this is the graph of this function. So I know the domain has to be this. But since I can't graph this, I don't know what that looks like, and I don't have a calculator, all I would do is I'd take the inside part. I'd take the inside part and just say, I know that it has to be greater than 0. Well, parabola I can do. Now I can do this with sign analysis, or I can do it with thinking about the graph. So what I do first is figure out where it equals 0. Where does this equal 0? Plus or minus what? Plus or minus 2. Do you agree? Pretty easy. So then I can do a sign analysis. I can go from negative infinity to negative 2. I can go from negative 2 to 2. And then I can go from 2 to infinity. Okay? And then what I do is I do a test value. You can test 0. If I put 0 fits right here. If I put 0 in, what's 0 squared minus 4? Negative. So that'd be negative, and then signs will alternate because they always alternate unless you have multiplicity that's even. And then I'm looking for where it's positive. Where is it positive? Here and here. That's why the domain is what it is. So when you found these critical values, you found 0 and plus or minus 2. Well, that's 0 is definitely not included, and plus or minus 2 is not included. Because remember, you can't take the natural log of anything that is negative or equal to 0. You can't take the natural log of 0 and see if I plug in a 2 or a negative 2, that's going to give me 0. And then if I plug in anything between negative 2 and 2, that's going to give me a negative number, and you can't take the natural log of 0 or negative. Everybody say it with me. What can you not take the natural log of? 0 or negative. I'm so pumped today. Here we go. Number 6. This one right here, take a derivative. You end up with this. I would have, most of you know that when you take the derivative, this is really x squared plus x squared. She's not showing the work for the derivative. But you take that to the 1/2 power and do the derivative with simple power rule with a chain. So it'd be 1/2 times x squared minus 9 to the negative 1/2 power times 2x. Those 2's will cancel. The x will end up on top, and the square root of x squared minus 9 will end up on bottom. Do you see how she got her derivative? Now, I want to see where the derivative equals 0. Well, the derivative equals 0 at 0. The top, where the top equals 0. Why are they throwing out 0? Must not be in the domain. We'll go there in a second. We'll check the domain. And then I took the bottom equal to 0. I mean, it's a square root, but does the square root matter? No, because you're going to square both sides. The square root's irrelevant. You just look at the square root of x squared minus 9, set it equal to 0, and you get plus or minus 3. These are the critical values. Well, how do I know they're the critical values? She did a graph again. Let's check it with a sign analysis. What do you know about a square root? If you wanted to do domain, for a square root, let's come over here. I'll do it in blue. Square root of x squared minus 9. What do you know about a square root? What can you not take the square root of? So what does x squared minus 9 have to be? Positive. Could it equal 0? Can you take square root of 0? Yeah. So you can be greater than or equal to 0. So find your critical values for that. What do you get? Or find your values where it equals 0. What does it equal 0 at? Plus or minus 3. So if I did a sign analysis, it'd be from negative infinity to negative 3. Yeah, but you got to know which ones to cross out. Okay? So then, hold on, listen, so I can tell you which ones to cross out. So you have to check the domain always. And that's actually going to be one of the points on your assignment that you're going to do is you're always going to check the domain first. So the domain here is you cannot take the square root of a negative. So I just take x squared minus 9 and say it's greater than or equal to 0. So I get my zeros because I'm going to do a sign analysis. So figure out where it equals 0, plus or minus 3. And then I do test values. Let's test 0 again. If I test 0, what's 0 squared minus 9? Negative, so be plus plus. Or some people do the sign analysis this way. Jada might be the person that says, I don't do test value, Mr. Morris. I know my graph. X squared minus 9. Everybody show me what x squared minus 9 looks like. Both up. So look at the ends of your sign analysis. Aren't they both positive? And then you know it alternates. So you can do it that way if you don't want to do a test value. So then the domain for this function is this. Well, my critical values, negative 3 to 3, is included because I'm allowed to be what? So my domain is actually negative infinity to negative 3 included, union 3 to infinity. Do you agree with that for the domain? This is the domain. Now what Jean did, she cheated. She just graphed the function with her calculator and saw the domain was going to be negative infinity to negative 3 included, 3 to infinity included. Yeah, Jean, she used a calculator. They're not going to let you use a calculator to do domain on the AP exam, I know. That's one of the things they want you to know how to do by hand. So this is the domain. So when you found your critical values, you set your numerator equal to 0. Is 0 in that domain? Is 0 in that domain? No. 0 is not in that domain. Is negative 3 and 3 in that domain? Yes. Sorry. Yeah, I got you. All right. Critical values again. Here's the nice thing. Look at number 7. 7, everybody can do the domain for 7. What's the domain for 7? Double bar R. That one's easy. So you don't have to throw out anything. So you took a derivative, factored it, set it equal to 0, got 5/3 and negative 2. How many of you got those for critical values? Me too. I did too. Number 8. This is nice. That's a nice. Let's do number 8 together.
I did not do number 8. So
Number 8 will do. I'm going to skip number 9. The only thing not in the... This is an easy one to check domain for. Look at the original equation. What cannot be in the domain of a fraction?
0.
So don't want the bottom to equal 0. So what I'm going to do is figure out where it equals 0, which is plus or minus 3, and say the domain is what? Domain cannot equal plus or minus 3, you crazy people. So whatever, if I get that for a critical value, what do I have to do? Throw it out. Now, what rule did I use to do the derivative for number 9? Quotient rule. Okay? Derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Distribute, collect like terms on top. You end up with this. Yada, yada, yada. Plus or minus 3 when you set the bottom equal to 0. That's critical values, but we have to throw them what? Because they're not in the domain. What about the top? What about x squared plus minus 3x plus 9? If you do quadratic form, it doesn't factor, so then you'd have to run it through what? And it's imaginary. You would throw them out. Okay, I'm going to show you quadratic formula there. It'd be x equals, somebody tell me a quadratic formula. Blake, tell me a quadratic formula in celebration of your state victory.
B plus or minus the square root of b squared minus 4ac.
There you go. You guys sing it. Negative b plus or minus squared, plus or minus squared, b squared minus 4ac, b squared minus 4ac, all over 2a. So if I plug this in, what would it look like plugged in?
Plugging in what?
Quadratic formula. This part, quadratic formula. You don't have to worry about the negative 2. It's factored out.
You skip the 2.
If I factor it out, I don't need to use
So
it.
3
3 plus or minus
square root 9
9 minus, shh,
4 times 1 times 9.
I can pretty much stop there. Over 2 times 1, because this is going to be 9 minus 36. Is that going to be imaginary? Boom, throw it out. As soon as I see it's imaginary, I'm throwing it out. Okay, number 10. This one's a super fun one. You get, what the heck did they do here?
Oh, I did not get that.
Oh, they did. She did product rule. Derivative of the first is 1. Sorry, she went x. She went the first function times the derivative of the second. So she went x times 1 over x. That's where she gets x over x. So she went the first function times the derivative of the second. Product rule, does it matter what you do the derivative of first? And does it matter the order? No, because it's, guys, because it's all multiplication and addition, order doesn't matter. Plus, the derivative of the first is 1 times the second. So do you see how she got her derivative?
Yes. She did the product rule.
Thank you. Now, x over x is just 1, so she got 1 plus ln x. She sets it equal to 0. She gets ln x is equal to negative 1. You have to go full circle, so e to the negative 1 is equal to x. Anytime you solve a log, you got to go full circle. Ooh, we're going to have to remember that. That's going to come up a lot soon. So we got e to the negative 1, so my critical value is 1 over e. And that's okay, because the only thing not in the domain here would be, what's the domain for this function? Greater than 0. Is 1 over e greater than 0? Yeah, it's positive. You're good. I'll go back and do number 9. Now we found EVTs. Now you actually had a closed interval. So this is where you actually closed off the interval. You found your critical values, and you check endpoints and what? You check endpoints and what? You check endpoints and CVs. All right, I got 2 CVs, 0 and 4. But which one am I not going to use? 0, because it's not my interval. I'm only going to check 4. So I'm going to check 1, 4, and 6. I plug them in. Where do you plug in when you do the candidates test?
The calculator?
Nope. This is not. Oh, yeah, they did use calculator. Okay, where do you plug in?
0, or the original.
Original equation. Plug in the original equation. And if you have a calculator, certainly use it. Okay? All right, so you got a max of 8, x equals 6. Got a min of negative 24, x equals 4. Your assignment, your 20 problems, no calculator. All right, number 12. Find the derivative, set it equal to 0. I got 1/3 and negative 1. Those are both in the interval. So I got to check all these. And this is what yours is going to look like without a calculator. Negative 3, negative 15, negative 1, 1. 1/3 negative. Yeah, you will get a really goofy one. Negative 5 over 27. 333. Absolute max is the largest. Absolute min is the smallest. That's all you do.
Why does she write them like
Huh?
that? Why does she write them?
What do you mean? Why did she write them?
Like in the table.
Huh?
Like in the table, like I just wrote f of negative 3 equals
that's what I
negative
do.
15 absolute.
That's fine too.
Okay.
Yep, that's fine too. All right. Yeah, you're fine. This one right here, a little shiesty. I had to, so take the derivative of this. You end up with root 2 minus secant tangent. I'm going to tell you right now, most of you on that one, you're setting that equal to 0 with the calculator. So here's what you're doing. Everybody get your calculator out. Okay, ready? You're going to y1. Okay, I'm going to type it in. You're going to y1. You're going to type in root 2 theta minus secant theta tangent theta into y1. And I'm going to show you how to use the calculator. And I want from 0 to pi over 3, so let's keep that in mind. So here we go. Calculator, get it out. You better pay attention on this. Here we go. So it's root 2. I'm moving, people. I'm moving today. Minus secant. How do you do secant on your calculator? You got to do 1 over cosine. So you're going to have to go 1 divided by cosine of theta times tangent theta. And I had to use multiple parentheses there.
X with the root 2?
Huh?
Do you have to have an X with the root 2?
I think I'm setting the derivative equal to 0. And I think root 2 theta, the derivative of root 2 theta was just root 2. Is that correct? All right, so is that my derivative? Now, I'm going to set, if you want to zoom 6 it you can to reset your window, because I don't have a clue who had these calculators. The other thing I'd make sure is press mode, make sure it's in radians, because if it's not, your calculator is going to look like a straight line like mine does, which mine was not in radians, so mine looks like a straight line. Make sure it's in radians. Now press zoom 6. There, it should look like that. Okay? It's a genie in a bottle. You gotta like it. I don't know. Yours is a drunk bottle. Anyways, all right. So you can reset it later. It's just they changed the colors. All right. So, does everybody got these bottles looking things? These wine bottle looking things? Funny thing is, I don't drink it all, but whatever. Besides the point. But anyways, I drink pop. All right. Lemon water. I'm drinking water, track season. All right, now here's what you do. You're going to change your window from 0 to pi over 3. So everybody press window. Let's just set it up from 0 to pi over 3. That's all I need. That's all I need. All right, so x min is 0, x max is pi over 3. How do you do pi over 3? You type in pi over 3. There we go. I don't care what it's labeled by. The x scale doesn't matter to me. I really don't care. I don't really care about the y min and y max either. All I care about is when I set a derivative equal to 0 is where it crosses the what?
X-axis.
If I'm setting, you need to listen to me, because on the calculator part of the AP exam, if you have to solve a derivative equal to 0 with your calculator, you need to type the derivative in, and you need to look to figure out where the derivative equals 0 is simply looking for where the derivative crosses the what?
X-axis.
Where does it cross the x-axis? That's what we're going to find. What do we use? Second trace. What option do we use? Option 2, zeros. Now, it's going to ask you 3 questions. Left bound, right bound, guess. Left bound, you're going to make sure you're to the left of where it crosses. If you're to the left of where it crosses, is it above or below this time? That will change depending on how you cross. Now, I'm going to get pretty close. It doesn't have to be perfect. Just make sure you're above. If you don't know for sure, look at the bottom of your screen and make sure the y value is positive. Hit enter. Now I'm going to do a left bound. Make sure it's below. If you're not sure, go to the bottom of your screen. Make sure the y value is negative. Press enter. And then you'll have to hit enter a third time for a guess. I don't have to, but I get 0.7854. Is that what you got? I'm going to carry all the decimal places to my paper that I can write. She rounded, but that's Jean. She does those things. Okay, but we're not rounding. We're using 0.7854. All right, so there it is. So now, I need to plug into the OG. So I need to plug in my candidates test. I need to test 0. I need to test this critical value, and I need to test pi over 3. So now I'm going to go back to the calculator. I should have put the OG into y equals. Let's put the OG into y equals. Can anybody tell me what the OG was? Root 2 theta minus secant theta, which will be 1 divided by cosine theta. All right, let's put the OG into y equals. Now, here's the way I can do it. You can either do the table. You can go to the table and look for the values. My table's not set up right. How can I fix my table?
You gotta go to table set.
Where's table set at? Second window. You can change your table start to whatever you want. I'm going to change it to 0 because that's the first value I want. And then I'm going to have it count by ones because that just makes more sense. And then I can go get the 0, -1. So I got 0, -1. How can I go get 0.7854? Change the table set to 0.7854. Okay, so I'm going to change the table set to 0.7854. Is that right? Or 7845? What was it?
Or you could have it, instead of being independent auto, you could have it ask. So that way when you.
Oh, yeah, I forgot it can do that. Okay. If you go down here to independent auto, you can have it ask in the table.
Second window.
And then you can just type in your X value into the table. So I don't like doing that because then you got to change it back because sometimes you need to look at the whole table. But if you want to do that, you can. If you know to change it back, put 0.78, what is it, 0.7 what?
8.5. It's also pi over 4.
Yeah.
Yeah, I would.
Well, I don't know. Yes. Yes. If you knew it was pi over 4, good for you. Okay. But 0.75, let's just pretend that most people didn't know that. But if you did know that, good for you. All right. What do we get there for the Y value? What do we get? You need to highlight it to see all the decimals. Highlight the Y value to see all the decimals. Otherwise, it's going to round it. All right. Now, you can do this auto ask again. So now we can clear out that. Now we can put pi over what's the other endpoint we got to test? Pi over 3. So you can go second pi divided by 3. Hit enter. And now we got your pi over 3 value. So if you want to change your table setup to auto ask the independent variable, you can do that. Another way you can do it that some people like, and that this actually works pretty fast too, is everybody go to your home screen. I do want you to practice this because we will use this quite a bit, especially when we get to integrals. Go to vars, y vars, function y1. And you can just type in the value on it. It's kind of like the ask auto independent. So I can do 0 and hit enter. Then, watch. I don't need to do vars, y vars, function y1 again. If you just hit, you can either go up and highlight it and hit enter, or if you just press second enter, it'll copy paste the last line. Second enter, copy paste is the last line. Then you can change the 0 to what?
Any number you want.
0.7854. Hit enter, there it is. And then press second enter again, and then I can type and change it to pi over what? I think it was pi over 3 was the other endpoint. Okay, is that okay? All right. So that works pretty slick. So whatever you want to do, whatever floats your boat. All right, number 14. This is a good one. By the way, there it is, the answers. The absolute max was negative, was the critical value. And the absolute min occurred at one of the endpoints. Okay, number 14. I need everybody to pay close attention to number 14. When you do 14, you got y equals 3 e to the x minus e to the 2x. Whenever you do a derivative with e's, Blake, after you get your derivative, factor out the e if you can. Trust me, it is awesome. It's going to make your life simpler. If I can factor out, now some people are like, how do you factor out an e to the x? You got e to the x, you got e to the 2x. You can factor out one of the e to the x's. Because you're going to subtract exponents anyways, aren't you? So you take out the smallest exponent. Is e to the x smaller or e to the 2x? E to the x, duh. So we're going to take out e to the x, and that's going to leave me with 3 minus 2e to the x. Because when you take and divide both of these by e to the x, this e to the x will cancel. This one, e to the 2x, divided by e to the x, you subtract the exponents, gives you e to the x. Is everybody okay with that? Then you set each one equal to 0. Here's the best part. You ready? E to the x equals 0. This sucker can never equal 0. Tell me why. Tell me why. Ain't nothing but. Y cannot not equal 0.
E is not 0.
Well, no.
Remember, and if you.
What kind of graph is it?
Oh.
It's a J curve. Does a J curve ever hit 0? J curve never hits 0. Or some people are like, well, what if I forget the graph? What if Blake forgot the graph? Because that could happen. I totally could see that. Then Blake's like, how do I solve an e to the x equation? I take the ln of both sides. Because we learned that in pre-calc. If I take the ln of both sides, I get ln of e to the x equals ln of 0. And then you're like, oh, duh, I can't take the ln of what? 0, so I throw it out. Now the next one, you do have to do the ln. So I'm going to have 3 minus 2e to the x equals 0. I'm going to move the 3 over, divide by negative 2. So I move the 3 over, it gives me a negative 3. I divide by negative 2, it gives me 3 halves. Then I take the ln of both sides. You better learn to do that. I take the ln of e to the x, that cancels the ln e, and pull the monkey out of the tree, you get x. And then you have ln 3 halves. So that's my critical value. My critical value was ln 3 halves. So you test your endpoints and your critical values, and this is what you get. I need to finish this up. Okay, the last two, just check them. I can take time to do one of those tomorrow. I need to finish up. I need to get to the next stuff.
Oh, you still have to do problem number 8.
Yeah, I'll do that tomorrow at the beginning of class. Okay? There it is. If you want me, I can work on some more of these later as we go. Wednesday morning, I can go back. Actually, Wednesday morning, I'm saving them. So I'm going to get first thing Wednesday morning. Any of the other questions that I didn't get to go over here that you'd like me to see do with EVT, I'll do Wednesday morning. All right, go to your notes. Here we go. Today is the best day because we're doing first derivative test. Love it. It's super simple. This next 2 sections, you're going to be like, man, this is awesome. This is easy. It's like the easiest calculus we've done. This is what your big assignment's on. Okay, the first derivative test, increasing and decreasing functions. The reason this is going to be so easy is because I basically already taught it to you. If you remember doing particle motion and doing sign analysis for velocity and all that, it's basically the same thing because velocity is really the first derivative test. And where velocity was positive and negative is where it was moving right and left. But what we're going to do is just say generically, it's where the original function either increases or decreases. Okay, so let's look at this. Determine intervals on which the function is increasing or decreasing. Well, the derivative is the what? What is the derivative, everybody, of the function? What does it represent?
The rate of change.
It represents the rate of change, the slope of the what? So where the derivative equals 0 is where the original function is going to be what?
Stationary.
Sorry. Did I say derivative equals 0?
Yeah.
Okay, good. That was good. Where the derivative equals 0 is where the function is at rest or where it's going to be a peak or a valley. Because at a moment, when you get to the top, what happens to the object? It stops. It goes up, then it stops, and then it comes down. For just a moment, it's at rest. Okay? Same thing at the valley. Where else can it occur? Not just where the derivative equals 0, but where it has what?
Undefined.
Undefined, which are points of non-differentiability, which are corners, cusps, and... Now, we don't include discontinuity. Discontinuity is still a bad thing. We do not want it to be discontinuous. Okay? We don't like that. But if it is, it will be a place where the derivative is undefined because discontinuity automatically shows up as what? Undefined. But if we have those critical values for discontinuity, what do? What did we do in the homework when we found critical values where the original function was undefined? You throw them out because it's not in the domain. So yes, they're going to be undefined in the derivative, but they were undefined in the original. They're not in the domain, so we have to throw them out. All right, so here's the deal. This is what I was supposed to say. Where the derivative is positive is where the original function is going to be what? It's going to be going increasing. Now with velocity, we said moving right, but we're not doing velocity problems anymore. So where the derivative is going uphill, where the original function is going uphill is where the derivative is going to be what? So right here is where f prime is positive. Okay, f prime is positive. What does that tell us about f? F is what? Increasing. Okay, this right here at A is where f prime would equal what? At x equals A, you have a potential relative extrema. You can look at it and tell what it is right now, but we're not going to have the graph. You're going to have to figure that out on your own. And I'm going to show you. It's called the first derivative test. All right, what's happening from A to C? It's going downhill. So what do we know about our derivative there? F prime is negative. So then F is what? Decreasing. What's happening at C? Well, it's equal to 0, so it's a relative extrema. I'm going to come back to B in a second. Then we go from C to D. What's happening again?
Increasing.
The derivative is positive, so therefore the function is increasing. The derivative is positive, therefore f is increasing. What happens at D? F prime is undefined. It's a cusp, which is a possible relative extrema. What's happening from B to E? And from E to F? F is decreasing because F prime is what? F prime is less than 0, so F is decreasing. I meant to say is, but whatever. All right, let me talk about two other points that I didn't mention here, and that's special points B and E. Does anybody know what's happening there? The slope of the tangent line's not changing. No, B and E are definitely not relative extrema, they're not relative mins, they're not relative max, they're not peaks or valleys.
E looks like it kind of flattens out there.
It does flatten out there. That is a slope of 0 there. We could say that's a slope of 0, but there's something about this point. Does anybody know what? They're not relative extrema. I have mentioned this before, very briefly, so it'd be a shot in the dark if you got it. Yes? It changes concavity. So what happens if you look at this? This is concave what? You see that? It's concave what? No, that's not concave up. What is that? Concave what? Down, okay? All right?
We're still learning.
All right, you're still learning. This is concave what? Up. If it holds soup, it's up. If the soup gets dumped out of the bowl, it's down. Okay? All right, this holds soup. Think about cupping your hands. Are you cupping your hands up or are you cupping them down? Okay? Cupped down, cupped up. Okay? Say this. Curved up or curved down? So concave up, is it curved up or curved down? So look at it. From A to B, is it curved up or curved down?
Curved down.
That's concave down. Write that down. That's funny. All right, what about, I should have put that in blue. Let's put that in blue. Yeah, you should be writing all this. Concave down. What about the green part? It's concave what? Concave up. What about from D to E? Shh. What about from D to E? Curved up or curved down? From D to E. Curved up. It's curved up. So that's concave up. What about from E to F? Curved down. Very good. Curved down. Now, what do you notice happens at B and E?
Oh, it changes
The concavity changes. That is special. Would you like to know what it's called now?
Yes.
I've told you. Why are you asking? It's called a POI. Point. Yes, I have said it. It's called point of inflection. I've just never abbreviated it for you. You do get to abbreviate on your big long assignment, Blake. You do not have to put point of inflection. He can put POI. You're going to love it. They love multiple choice questions where they ask about POI. Love it. So, I did all the gene exercise. We're done. Let's go down. We don't get to color. Sorry. We answered everything. We skipped all our coloring crap. I don't feel like being in preschool today. Okay? No, we're on page 282. So, definitions of increasing and decreasing. A function, are you paying attention? A function f is increasing on an interval if for any two numbers, x sub 1, x sub 2, in other words, you got x sub 1 and then you've got x sub 2, so in order from left to right, we're just traveling left to right. So if you take an x value and get to the next x value, and it implies that x1 is less than x2, so we're saying x1 comes first, then x2. Is everybody with me there? If f of x sub 1, if the y value at the first x is less than the y value at the second x, what's happening? It's going uphill. Now, I also want to make a note here. This is going to happen where f prime is positive. Please make that note. That's important. Okay? We might have to do a little bit more note taking tomorrow. I don't know. We'll see. We're going to get there, though. Don't worry. Today and tomorrow will be to where you can start your assignment. A function is decreasing if for any two numbers x sub 1 and x sub 2. Okay? You got to be listening. Got to be listening. X sub 1, x sub 2. So we go from here to here. So one x value to the next x value, they're still saying x sub 1 comes first, then x sub 2. You tracking? But this time, they say at x sub 1, you have a y value. And then x sub 2, what happens?
It's lower.
That y value is lower. So what does that mean? Duh. So that would mean that f prime is going to be what? Negative. Your derivative is going to be negative. That's where we're going to get into the sign analysis. So let's take a look here. Example 2. Okay, the graph of y equals f of x is shown at the right, defined on the interval from negative 3 to 7. List the open intervals. Open. Everybody say open. Let's be open here. Okay, over which the function is increasing, decreasing, or constant. Real quick, can anybody tell me where it's increasing? Where does it look like the y values are getting bigger as you go from left to right? Negative 3 to what? Negative 3 to negative 1. And we'll do open intervals. When we do increasing and decreasing, Molly's going to ask, so I'm going to answer it now. Molly, when we do increasing or decreasing, we never use brackets.
I didn't hear that.
Okay? Never use brackets. All right? I don't know if Molly had asked, but I'm just saying. She might say, do we use brackets? No, we always use parentheses. All right, where is it decreasing, everybody? 2 to 7 parentheses. Thank you, Molly. And then now, constant, though, that's going to be where it has slopes of what? Everybody write a note to yourself. Constant slope of 0. Okay, that's where it's going to peak out. And it actually peaks out and it stays there for what? Plateaus, actually. Ooh, a little geography. Okay, that's from what to what? Negative 1 to 2. Parentheses always. Now, just a note here. A function is said to be monotonic, which means one tone. One tone. Okay, and this actually it overlaps into music. Mono meaning one, tonic meaning tone, but basically what that means in music is that it's strictly increasing or strictly decreasing. Okay, so like on like a scale or whatever, like your tone is the same. So it's either like monotonic in music would be the same tone, like you just play the same note. So if you had a function where it was just increasing, that's all it did. Can anybody think of a function that all it does is increase? Y equals x. What else? Give me something not so boring. J curve. That's not as boring. What else? R curve. R curve. Shooting star. Those are strictly monotonic. Can anybody give me one that's strictly decreasing?
Boomerangs.
Negative x squared.
I always get these wrong.
Boomerangs? Let's draw boomerangs.
Oh, yeah,
I swear. I always
It is strictly decreasing. You are correct. Good job. He cooked it up. Okay? Boomerang. Except at 0. So technically no. All right. In there.
It says which need not be continuous.
Oh, which need not be continuous. So you're good again. You're good. So, strictly monotonic. Shh. Everybody, shh. Quiet, quiet. We're too excited. Strictly monotonic. Everybody make a note to yourself. Your sign analysis, your first derivative sign analysis is either all positive or all what? Negative. So strictly monotonic means when you go to do your sign analysis for your first derivative, it's the whole thing's either going to be positive or the whole thing's negative.
For every single one.
Every single one, except for possibly at a discontinuity. Okay? Now, how do we find x values where the function is increasing, decreasing, or constant? It's important ideas to keep in mind here. If f of x is a continuous function, then the derivative can only change signs at critical values. Think about it, like a polynomial. If you have a polynomial, the only place you're going to change signs to go from increasing to decreasing is where you have peaks and valleys. But if you have a discontinuous function, like a boomerang, or more importantly, like a volcano. Think about a volcano for a second. A volcano is what first? Increasing. Then a volcano what? Decreases. But the critical value would be where it's not equal to 0, but where it's what? Undefined. It'd be where the first derivative is undefined because you're going to have that discontinuity. So that discontinuity is actually going to create the change in sign for your first derivative. So when you go to do your first derivative for the volcano, for example, from negative infinity to 0, it's going to be positive for the first derivative because the slope of the tangent line is positive. From 0 to infinity, the slope of the tangent line is going to be negative. So when you went to your first derivative, you would have positive, negative is what the sign analysis is going to be. And you'll see when you do it. Like, I can think about these things without doing it. So a discontinuous function, the derivative could change signs at the critical value or a discontinuity. So cool. All right, we're going to do an example. So I'm not even going to look at our directions because I'm going to show you the way I want you to do it. Okay, here we go. Number 1. All right, just like EVT. But you want to know why this is different than EVT? Look at the question. It's not even asking the same thing. It says find the and this is what your big assignment's on. In fact, this is the first 4 points of your big assignment for every problem.
Could you help me with something?
Get out of the way here. Get out of here.
Yeah.
Golly, I'm so annoyed. All right. Knew it was going to come by today. They got swept this year. All right, find the open intervals.
You got swept?
They got swept. Find the open intervals. Shh. Nobody cares. Okay. Find the open interval on which it's increasing or decreasing. This is not an EVT problem. What does EVT ask for?
The extremos.
It asks what the absolute max and min is. And if I wanted to find the absolute max and min, EVT only works if you have a
Restricted area.
you got to have a restricted interval, a closed interval. So they don't even have a closed interval, and they have nothing in this problem. Are they asking about absolute max and min? All right, but shh, there's way too much talking. Shh. But your first step is exactly the same as EVT. You're gonna love it. Take the derivative, set it equal to what? 0 or undefined. All right, now this is a polynomial. Is it gonna have anywhere where the derivative's undefined? No. So we're just going to be setting the derivative equal to 0. So take the derivative. Do it right now. Write it down. Quit not writing stuff. Here we go. 3, that'll be 2x squared minus 2x minus 4. All right, there's my derivative. You are going to get a point for that on your assignment. That's 1 point. Plus, I forgot, you're also going to get a point for telling me the domain. So real quick, what's the domain for all polynomials?
Double bar R.
You are also going to do range, but I'll get into that later. We'll do range tomorrow because you can't really do range until you get the final graph done. All right, so I'm going to set the derivative equal to what? 0. And you'll be like, oh, this is easy. Okay, so we're going to go 2x squared minus 2x minus 4 equals 0. Let's go with Yanel. This is set equal to 0. Can I factor this at all? Is there anything that can factor out of it? We can take out a 2. Now, some people are like, do I have to leave the 2? Does it really matter? It matters in your sign analysis if it's negative. But since the 2's positive, is it going to affect your sign analysis at all? No, so it really doesn't matter. So you can actually drop it if you want.
You don't have to.
I just never drop it. I leave it. Some people are just like, I just ignore it. I guess I technically wouldn't drop it off and just get rid of it, but you just don't need to pay attention to it because it's not negative. It's not going to affect anything. Then we're going to get 2 times, I believe, x minus 2, x plus 1. Is everybody in agreement? Okay. All right, what are the critical values? The 2's not going to matter out front. So what are the critical values? 2 and, all right, you're going to get points for that on the big assignment. So you already got 3 points. Okay. Now you're going to, because there's a second derivative test and there's concavity and there's all kinds of stuff. Now you got to do the sign analysis for every problem. So here's what we're going to do. We're going to set up the sign analysis for f prime. So everybody label it f prime. And some people like to put their SA, sign analysis. They don't like to write sign analysis out, so just put SA. All right, so we're going to go from negative infinity to negative 1. We're going to go from negative 1 to 2. We're going to go from 2 to infinity as long as there's no even multiplicity. Does everybody know what even multiplicity is now?
Bounces.
That's when it bounces. The only way you get even multiplicity is if these show up more than once. Like this would have to be second power or fourth power or sixth power. Odd multiplicity would be like 1, 3, 5. Odd, the sign analysis always what? Alternates. Even multiplicity, the graph's going to bump in the derivative, so that means it's going to stay positive, positive for the derivative, or negative, negative for the derivative. So this is definitely going to alternate. So in your derivative, okay? All right. So I would test 0, okay? Or you can look at your derivative and say, oh, this is a problem going uphill. So you know it's up at both ends. You can do that. But I'll test 0. I always do tests. I do test values. 0 makes this what? 0 makes that what? Positive. Plus 1. I don't even care about the 1. I just care it's positive, right? So we got a positive, we got a negative, and this 2 is already positive, so that doesn't, see why I said that 2 doesn't affect anything. So it's negative, so signs will alternate. So here's what you get to write. So you get to say increasing, decreasing, increasing. Now, on the AP exam, they cross out your sign analysis. You actually have to write this out. You actually don't get to label your sign analysis on the free response. You have to actually write a sentence that says f is increasing from negative infinity to negative 1 because f prime is what? You have to do that for me on this assignment because I got to train you for the AP exam. Because what the reader is instructed to do, the AP reader that's grading your AP exam is instructed to cross out every one of your sign analysis. They want to see if you look at the sign analysis and know what to write. Okay? No, you're not. Okay? All right, so we're going to say f is increasing. I don't know why I said in. F is increasing. And you can abbreviate increasing, I and C. And we're going to write both intervals. Where is it? From negative infinity to what? Negative 1 union 2 to infinity. And you have to say the because. Because f prime is what? And you can just put greater than 0. You have to write that. Now do you know why my assignment takes so long? Okay, and I'm not even done. Tomorrow we got to find maxes and mins, and then you got to say where the maxes and mins are, and you got to plug them back in the original equation to figure out the maxes and mins. And then we got to go to the second derivative and do all the concavity stuff.
So now do you have to write
Now you have to say f is decreasing from negative 1 to 2 because f prime is less than 0.
and now we're done?
Now you're done so far. Tomorrow I'm going to add maxes and mins to it. All right. So here's what I'd like you to do tonight. Okay. I would like you just to do the first 4 problems on page, because you're going to have so much homework this week. I'm not going to kill you yet. Page 287, 1 through 4. Page 287, 1 through 4. Yes, I'll make you turn it in. Okay? You might want to review number 2. I'm going to give you a hint. It's a product with a chain. You're going to have to factor out at least power. Factor out least power. Power.